So your actual processor, your CPU, if you break it down and look in more detail about the components that are on it, it's made up of about nine that I really want you to know in a lot of detail. Okay, so nine of the components. If you think of these black lines as buses, okay, that connect the components together, um, the components themselves all have very specific jobs, and it's important that you learn what those jobs are so you have a really good understanding of um, your CPU. So the first one is your program counter. So this holds the memory address for the next instruction you are going to execute. Okay, you'll understand this all of these components in a lot more detail when we do if you watch the fetch execute cycle video, because it will talk you through how they're all used. So program counter holds the memory address for the next instruction to be executed. Your memory address register holds any memory addresses which are about to be used by the CPU. So the memory address register connects directly to the address bus, which will connect to RAM. So if you want to send an address down the address bus, it's got to go to the MAR first. The MDR is very similar to the MAR, but it's for data. So it holds any data or instruction that has been fetched from or something that is waiting to go to memory. Okay, so if you want to go down the data bus to memory, or you're coming from memory with data, it's going to go to the MDR. The CIR is your current instruction register. So that holds a copy of the current instruction that you are running. These next two registers are less important to a sense. It's more when you get to the high-end GCSE and the A-level where I want you to try and understand these as well. So you've got a status register, which is essentially just an 8-bit number where each bit is a flag. Okay, so if you imagine zeros, if they're all zeros, all the flags are off. If one of those zeros becomes a 1, it means something to the computer, and it's usually to do with the maths. So it's the current operation. So we've looked at things like overflow. There'd be an overflow flag. There's positive and negative numbers flags, carry flags if you carry a bit. They're just flags that highlight the status of the current operation. You've then got the interrupt register. So the interrupt register is like a status register, but it stores details of any signals that have been received by the processor from other components attached to it. So if you imagine, if you're typing a letter and you're typing away and the processor is going through the motions of processing all those letters that you're typing and displaying them on the screen. A more important bit of hardware like the I don't know, let's say main memory RAM or the hard disk drive might want to interrupt what the computer is currently doing to say, I've got this to do and it's more important. That's what the interrupt register is for. So it would flag to the control unit, you need to stop what you're doing and do this other thing that's a bit more important. You've then got your control unit. So this is the bit that sort of bosses everything else around, all the other components. So this directs the operations of the processor and tells the other components how to respond. It's also responsible for the decode part of the fetch, decode, execute cycle. You've then got your accumulator. So this stores all the immediate results of calculations in the ALU. So that's not going to make a lot of sense to you. The way this got described to me once was, if you imagine your calculator, a normal calculator, as you type numbers into the calculator, you've got that sort of screen at the top. So it holds the sum before it's executed. That's sort of like your accumulator. So your accumulator is like that screen at the top of the calculator. So as you're typing, the sum could build in there. When you press equals, it will go to the ALU, work it out, and display the answer. So the accumulator stores the results of calculations or the sum prior to calculations. And finally, the ALU is an electronic circuit. It's a combination of logic gates which can perform arithmetic on binary numbers. So logic gates is part of the specifications, and sometimes people think they don't make it a lot of sense as why they're learning it, but actually logic gates, everything inside the computer works by logic gates. So all the maths that's executed is just combinations of logic gates that do the maths for you. Okay, and there's other videos showing you how that works. So I know that's a long video, it's a lot to take in, but they are all the internal components of the CPU and their specific jobs. You will understand them better as you start to become a CPU with the fetch execute cycle and follow through what the CPU is actually doing. They will hopefully make a lot more sense.